Okay, so I'm continuing every question that's ever been asked, and I'm now going to be looking at compound measures. Now this is the second part of this video because the first part was on speed, distance, time. The second part is going to be on pressure, force, area, and mass density and volume. So you can download this document, it is linked in the description, and I'm going to go straight through to pressure, force, and area. Now they always give you the formula for this, which always makes it a little bit easier. It says a force of 70 newtons acts on an area of 20 centimeters squared. The force is increased by 10 newtons and the area is increased by 10 centimeters. Helen says the pressure decreases by less than 20%. Is Helen correct? You must show how you get your answer. So let's work out then what the pressure is to begin with. And there's lots of different ways you could do this one, but let's work out the original pressure. It is the force divided by the area, and this is a calculator one, but 70 divided by 20 is 7 divided by 2, which is 3.5. And the units for this are newtons per centimetre squared, but we don't necessarily need to know this. Now we're going to do what the new pressure is. The new pressure is going to be different. It says that the force is increased by 10, so it's going to be 80, and the area is being increased by 10, so we've got 30. So we'll do 80 divided by 30 here, and 80 divided by 30 is 2.666 newtons per centimetre squared. Now, Helen says that the pressure decreases by less than 20%. Well, let's actually just work out what the pressure decreases, so what the percentage changes. The decrease is going to be the difference between them, so I'm going to do 3.5 minus 2.666 divided by the original, which is 3.5, and we will times that by 100. Now there are other ways of answering this. This is just the way that kind of makes most sense to me. So I'm going to find out the way that it changes. I'll do 3.5 minus 2.66, that's the amount of change that there is, and I'll divide it by the original, which is 3.5. I'll multiply that by 100, so it has decreased by 23.8%. So the decrease is a 23.8% decrease, and Helen says that the pressure decreases by less than 20%, so she's wrong. Helen is wrong, it was more than 20%. Helen is wrong, it is more than 20%. Now the other way you could have done this is you could have just decreased this by 20%. You could have done 3.5 times by 0.8 to find out what it is with a 20% decrease, and 3.5 times 0.8 is 2.8, and it has actually decreased by more than that because 2.6 is lower than 2.8. So there's a couple of different ways about how you might like to answer this one here, okay? But let's check we got this one right. So we've got no, she's not right, and I think, which bit did I go for? Yeah, the decrease is 24% instead. So actually we did get that one right. Okay, and then the second one on pressure, force, area, again we've got the little formula that comes with this. It says that the prism has a height of 3 and the volume of the prism is 18 meters cubed. The pressure on the floor due to the prism is 75 newtons per meter squared. Work out the force exerted. Well, we need to find out what the area is, and actually we don't have the area. What we've got is just the height of the prism, which is 3 meters, and we've got the volume. Now for a prism, the volume of a prism is equal to the area of the cross section multiplied by the length, and in this case it's the area of the cross section is the bit that's on the bottom here, and the length that we're talking about is the height of it, which is 3. So the volume is 18, the area is what we're going to find out, so I'm going to divide both sides by 3, so that must mean that the area is equal to 6. So if I'm going to try and use this formula where pressure equals force over area, I can just substitute in my values. The pressure is 75, the force is the thing that I'm going to try and find out, and the area is 6. So if I do 75 and I multiply that by 6, that will tell me what the force is. So I'm just going to work out 75 times 6. 5 times 6 is 30, and 7 times 6 is 42, plus on the 3 is 45. So the force is 450 newtons. Let's double check we've got this one right. Yep, we've got the 450 newtons just right there, okay? So now we're on to the mass density volume questions, and it's also got some stuff about the volume of a cylinder. So it says liquid A and liquid B are mixed together in the ratio 2 to 13 by volume to make liquid C. Liquid A has this density and liquid B has this density. A cylindrical container is filled completely with liquid C. The cylinder has a radius of 3 and a height of 25. work out the mass of the liquid in the container, give your answer to correct to 3 significant figures. Well, I think there's a lot going on here, so I'm going to draw a line. I'm actually just going to kind of like focus on just the beginning part of this question that we've got here. So it says that they are being mixed together in the ratio 2 to 13 to make liquid C. Now, actually, do I want to focus on that bit? I think we might need to actually include some of this information, because I think I need to find out the volume, first of all, of this cylinder. So let's actually focus on the part that's below the line. If I draw a quick diagram of the cylinder that we've got, and we're going to remind ourselves how we find the volume, it says that the radius of the cylinder is 3 and the height is 25. So I'm going to begin by finding out the volume of this. The volume is the area of the cross section, which is a circle, so that's going to be pi r squared, and you multiply it by the height, okay? So it's going to be pi multiplied by 3 squared, and we're going to multiply that by the height, which is 25. So I'm going to put that all on my calculator. So it is going to be pi multiplied by 3 squared multiplied by 25, which is 706.86, and that's going to be centimeters cubed, okay? And it says that they are going to be mixed by this volume to make liquid C. So of this volume, we want two of the parts to be from liquid A and 13 of the parts to be from liquid B. So let's now actually find out how much there is going to be of the volume of A and B. The volume of A to the volume of B is 2 to 13. So I'm going to take my 706.86, I'm going to divide it by how many parts there are, and these things here, they add to 15, and then I'm going to multiply it by 2 for A, and for B, I'm going to do 706.86, I'm going to divide it by 15, and I'm going to multiply it by 13. Why did I write A and then A? I should have written A and then B. Okay, so let's just quickly do these calculations. I'm going to do, calculators on the other side, no wonder I couldn't find it. I'm going to do my 706.86. I'm going to divide that by 15 and times it by 2. So for A, it is 94.25 centimeters cubed. And for B, I'm going to do 706.86. I'll divide it by 15 to get one part, and I'll times it by 13, so I've got 612.61 centimeters cubed. Now, it wants us to work out the mass of the liquid in the container, and this is where we're going to have mass, density, and volume. It goes mass, density, volume. So to find out the mass, I need to do the density multiplied by the volume. So for A, I'm going to do the mass of A. It is going to be the density, which is 1.21, multiplied by 94.25. I'm then going to work out the mass of B, which is going to be the density, multiplied by 612.61. And then the total mass, I'm just going to add them together. So I'm going to just go to my calculator, and I'm going to do those two calculations all at once. So that's 1.21 multiplied by 94.25 plus 1.02 multiplied by 612.61. And that total is 739 grams, because the units were in grams per centimetre, and that is to 3 significant figures. So we've got 739 grams. So we actually needed to start with the volume. We share the volume out, we find their separate volumes, and then we find their separate masses to find the overall mass of 739 grams that we've got here. Got another mass density volume question. They love doing these mass density volume questions where there are like two liquids being mixed together. So let's kind of see how this one goes. We've got the density of apple juice, the density of fruit syrup, and then the density of carbonated water. 25 centimeters cubed of apple juice are mixed with 15 centimeters of fruit syrup and 280 centimeters cubed of carbonated water to make a drink with this volume. Work out the density of the drink. So because it's going to be of the drink, we need to work out all of the different, because we want the density of the drink, we need to know the mass of the drink, and we need to know the volume of the drink. Well, the volume of the drink is nice and easy because they've just told us that it's 320 centimeters cubed, but the mass of the drink is the thing that I'm going to work out. So I'm going to work out the mass, first of all, of the apple juice. And the mass of the apple juice, if you remember our triangle that we have, it goes mass, density, volume. The mass is the density multiplied by the volume. So for the apple juice, it is going to be the density and the volume. So that's 1.05 times by 25. So we're going to do 1.05 times 25. It is 26.25. Okay, now I'm going to do the fruit syrup. So the fruit syrup that we've got here, we're going to work out the mass. It is going to be 1.4 multiplied by 15. So I'm going to do 1.4 times 15, which is 21. And now I'm going to do my last part, which is going to be the carbonated water. And the carbonated water is 0.99 and 280. So the mass is going to be 0.99. And we're going to multiply that by 280 to find out what the mass is. So that's 0.99 times 280 is 277.2. Whoops, 277.2. So the mass of the drink that we're going to work out here, the mass is therefore equal to the 26.25, the 21, and the 277.2. So I'm going to add those three values together. 26.25, 21, and 277.2. So the total mass is 324.45. 324.45. So now what I can do is, combining all of this together, I can say that the density of the drink is the mass divided by the volume, which is 324.45 divided by the volume, which is 320. And that's going to give me my final answer. So I think I've got the 324.45. I'm just going to divide that by 320. And it wants it to 2 decimal places, so it is 1.01. 1.01. I'm going to put that on the answer line of 1.01. So notice how we had to work out all of these masses first of all, and that told us what the total mass was. So these things here combined together to give us the total mass, which means I could do the final calculation of the density. And we do have 1.01 here as well. Okay, it says a gold bar has a mass of 12.5 kilograms. The density of gold is 19.3 grams per centimeters cubed. Work out the volume and give your answer correct to 3 significant figures. So it is mass, density, volume. Notice though, this is in kilograms, so we need to convert it to grams. 12.5 kilograms. If you times it by 1,000, you get 12,500 grams. The reason I have to change it to grams is because density is in grams per centimeters cubed, which means I need the mass to also be in grams. So we're going to work out the volume. Using the triangle, volume is the mass divided by the density. So it's the mass divided by the density. That is 12,500 divided by 19.3. And we're going to give our answer correct to 3 significant figures. So 12,500 divided by 19.3, and we get 648, and that's to 3 significant figures. I'm just going to put that on my dotted line here, 648 centimeters cubed. Yep, there it is, the right answer. Okay, the density of ethanol is 1.09 grams. The density of propylene is 0.97 grams per centimeters cubed. We've got 60 litres of ethanol mixed with 128 litres of propylene to make 188 litres of antifreeze. Work out the density of the antifreeze. So we're going to actually start off thinking about, if we're going to try and find the density of the antifreeze, from our triangle that we have, we know that density is the mass divided by the volume. So we need to work out, for the antifreeze, we need to know the total mass and we need to know the total volume. Well, the total volume is actually really easy because they've already told us that it's 188. So this is the total volume. This is the thing that we're going to try and find out. It's just like the apple juice and the fruit syrup kind of question. So I'm going to start with the ethanol. And we're going to try and find out the mass of the ethanol. Now the mass of the ethanol is going to be equal to the density multiplied by the volume. So we're going to do the density and the volume. That's 1.09 times 60, which is 65.4. Now I'll switch to my black part that I've got here. I'm going to do my propylene, and the propylene's mass is going to be 0.97. And there's 128 litres of this. So I'm going to do 0.97 multiplied by 128, and we get 124.16. So the total mass is going to be these two things combined. These two things will give us the total mass. And the total mass is 124.16 plus 65.4, which is 189.56. So if I want to work out the final calculation, which is that the density is equal to the total mass, 189.56, divided by the volume of 180, it's going to tell me what my density is. So I've got my 189.56, I'm going to divide that by 180, and because it wants it to two decimal places, it is 1.05. So we get 1.05, and the units are grams per centimetres cubed. Let's double check we've got this one. I've not got that one right. So what have I done wrong here? It should be 1.01. Let's see what I've got here. Maybe I've just typed it in wrong. Oh, I did type it in wrong at the end. The total volume isn't 180. I hope you spotted that earlier on. It's not 180. It says it right here. It's 188. So that was a very, very silly mistake. The whole method is completely correct other than that. So this is the kind of mistakes that can easily be made. I'm not going to take this out. I think it's useful to leave that in so you can see all these mistakes can sometimes get made. So we're going to do 189.56. We'll divide it by 188. And to two decimal places, that 8 is going to make it round up to 1.01. So it is 1.01. My apologies. I hope you noticed at the very beginning when I said it was 188. I hope you realised that when I wrote 180, that was the mistake I'd made. Okay, we've got another one of these mixing liquids. A and B are mixed to make liquid C. We've got the mass and density of A. We've got the mass, the density and volume of this. We want to find out the density of liquid C. Remember, if you're trying to find the density is the mass divided by the volume. So we need to find for C, we need to find out what the mass is equal to, and we need to find out what the volume is equal to. Well, I think what we'll do is we'll start off finding out these things for A. We've got the density and we've got the mass. So I think we need to find out the volume. And if you remember in our little triangle that we've got, it goes mass, density, volume. So the volume is the mass divided by the density. We are going to do the mass divided by the density. So that's 1,400 divided by 70. Now it's non-calculator, so luckily these zeros are going to cancel, and 140 divided by 7 is 20. So we have 20 meters cubed for the volume. And then for liquid B that we've got here, we've got the density and the volume, so I think we should find out the mass. And the mass is the density multiplied by the volume, so that's 280 multiplied by 30. Well, I'm just going to do 28 multiplied by 3, and then I'll add on the zeros. 8 times 3 is 24, and 2 times 3 is 6, add on the 2 is 8. So it is going to be 8400, and it's the mass, so it's going to be kilograms. So now we can work out what the mass is going to be for C. It's going to be the mass of A, which is 1,400, plus the mass of B, which is 8,400. And when we add these together, we get 9,800 kilograms. Now we're going to work out what the volume of C is. So let me just quickly highlight these where they came from. The mass of 1,400 came from here, and then the 8,400 here. Now we're going to work out the volume of C. So that's going to be the volume of A, which is 20, and the volume of B, which is 30. So you can see I got the 20 from here, and then I got the 30 from here. And so that is 50 meters cubed, which means my density is going to be equal to the mass, which is 9,800, divided by the volume, which is 50. So all I need to do now is just the last part of the division. I'm going to simplify it by getting rid of one of the zeros. I'm just going to do 980 divided by 5. So how many times does 5 go into 980? 5 goes into 9 once with 4 left over. It goes into 48 9 times with 3 left over. And it goes into 36 times. So our answer is 196 kilograms per meters cubed. Let's double check if we've got this one right. There is the 196 that we've got there. So you've seen there's quite a few questions that follow pretty similar patterns. Oh my gosh, yet another one. Okay, so we're going to find out the density of liquid C, really similar patterns to what we've got before. If we're going to try and work out the density, we need to work out the mass divided by the volume. So let's put this at the bottom of the page because I'm going to actually do some stuff with A first of all. So for A that we've got here, we've got the density, and we've got the volume, so I think we need to find out the mass, and the mass is the density multiplied by the volume. Density times by volume, so it's going to be 1.8 times by 80. Luckily we've got a calculator this time, so we can go really speedy, and 1.8 times 80 is 144 grams. So we've got enough information there. We're now going to have a look at B, where we've got the density and we've got the volume, so we're going to find out the mass. The mass is the density times the volume. The density of B is 1.2, and the volume is 40. So I'll do 1.2 times 40. And 1.2 times 40, come on calculator, it's just 1.2 times 40 is 48. So we have 48 grams. So for C, we can now say that the total mass is 144 plus 48. 144 plus 48, that is 192. And they've already told us that the volume is 120. So it's the mass divided by the volume, that's 192 divided by 120. And we get 1.6. So the density of liquid C is 1.6 grams per centimetres cubed. Let's double check we've got the right answer. Yep, 1.6 right here. So there were tons of questions on mass, density, volume, and loads of them of mixing two liquids together. Basically, you just need to know the total mass and the total volume. So if you don't have one of the masses or both of the masses, work them out and then just go from there. If you have found this useful, please do like the video, subscribe to the channel, share it with your friends who are doing GCSEs, because that just helps my channel grow and get to as many people as I possibly can do.